Hello again, friends, comrades, fellow creatures of life. This video lecture is in my philosophy and history of science lectures. This lecture will cover Thomas Kuhn, philosopher of science, and Emir Lakatos. All right. First, I need to hit this. Sometimes, my friends, the best ideas come between two cigars. Of course, that's not a cigar, it's a cigarella, but we're all just chemicals and stimulants. Anyways, Thomas Kuhn and normal science. I've wasted a minute already. This might be a long lecture. I'm going to try to get under 30 if I can. So Thomas Kuhn, in the philosophy of science, focused on the historical development of scientific theories, whereas Popper, as we have mentioned before, sought to answer what should be legitimate in establishing a scientific idea, aka the context of justification. Thomas Kuhn seeks to answer what conditions affect the conception of the ideas, as well as its maturation, acceptance, or rejection, aka the context of discovery. And so Kuhn writes on the history of scientific progress, or knowledge accumulation. Kuhn discovered a realistic picture of the progress, or increasement in knowledge, of science and scientific accomplishments and discoveries. He found that the process from ancient times until now was not linear, but rather there are instead many ideas with dead ends, false starts, contradictions, making the same mistakes, going back to the basics, etc. The Structure of Scientific Revolutions was a book written by Thomas Kuhn. In it, he talks about paradigms in normal science. He says that normal science is most day-to-day science or problem solving that happens under a broad set of presuppositional, unquestioned assumptions and expectations that govern our worldview, beliefs, values, behaviors, etc. The sorts of questions that are asked, how those questions are investigated, and how the results are interpreted. This framework he calls is a paradigm. Examples of paradigms could be in one of the natural sciences. We see physics. We still see shifts from Aristotelian view of physics, a Newtonian view of physics, and an Einsteinian view of physics. In biology, we see Aristotelian view of biology, a Darwinian view of biology, a Neo-Darwinian view of biology. In the broad sense of paradigm, it is a pervasive framework in which people see and interpret the world. The narrow sense of paradigm is a specific achievement that exemplifies or illustrates something in a broad sense. Normal science is slow, tedious, and repetitive. Most science is dedicated to solving puzzles, following the rules, using the imagination, and finding the solution to the puzzle. What happens when paradigms start to shift, though? What causes a shift? And Kuhn thinks that anomalies are not counterexamples. But what if there are too many anomalies that are researched into and then they will not go away? A paradigm is still assumed, however, until a better solution gives a more qualified evidential solution to the information puzzle. Consider the ether paradigm, the Michelson-Morley experiment, and Albert Einstein. Light propagation is not dependent upon the velocity of light source. It remains constant in its speed. Kuhn calls these processes normal science, unsolved anomalies, paradigm crisis, paradigm shift, and scientific revolutions. It is pretty much a paradigm shift is when we have so many things in our knowledge base that have been evidenced which causes a form or belief system or way in which we see the world to change. Alright, anyways, we have what's called pre-paradigm science, in which the paradigm develops, and then normal science then ensues. And then abnormalities to then develop within that paradigm, and then we get abnormalities explained within the current paradigm, and then we get back to normal science, or the abnormalities are ignored, disregarded, or regulated. The abnormalities accumulate then, confidence in the paradigm weakens, and then we have what Kuhn calls a crisis, which leads to a paradigm shift, and then normal science resumes. And so Kuhn's approach is a departure from the previous Enlightenment idea that the progress of science is a steady, consistent, linear accumulation of knowledge. Thomas Kuhn also suggested that paradigms are not rationally chosen, they cannot be chosen rationally. This view is controversial in particular, however, because Kuhn saw a paradigm shift as a religious or political conversion. So Popper suggests that the good scientist is creative. Kuhn agrees with Popper and open to criticism. Kuhn also rejects this, though. Kuhn rejects this because, positively, many scientists are, in a sense, slaves to the paradigm in terms of data. So science requires cooperation and consensus, which requires having the mind closed, in a sense, in regard to fundamentals. A scientist is brainwashed, in a sense, into putting trust into a paradigm and then working in accordance to that paradigm. Their education will pick apart a question unanswered in the paradigm and attempt to solve the unanswered question. Popper, however, said that open-mindedness helps scientists to demolish dogmatic thinking. Kuhn, on the other hand, said that both an open mind and a closed mind, a balance between the stability that a paradigm brings, but also keeping a creative open mind to challenges to aid in an assumed paradigm. Therefore, there needs to be a balance between the history of scientific development and the established paradigm and the philosophy of scientific development as well. Popper says that concerning scientific change, Popper thinks that it occurs via conjecture and refutation. Kuhn, on the other hand, thinks that change is within the paradigm. Change happens within the paradigm itself through a standards of progress and the standards of justification, and that he also thinks that change happens according to revolutionary science, which has no standard at current. Technically, all scientific truth is relative. Thomas Kuhn gives a gestalt shift of a paradigm shift, an elimination of an old perspective and a total change to a new perspective. So this is not, according to Kuhn, a change based on evidence, but on preference at any given time. Okay, so what makes the crisis is called the incommensurability of paradigms, which means that there is no metric upon which the paradigm can be compared in a purely rational, objective, scientific way. With respect to the meaning of terms, mass, according to Newton and Einstein, it is the same term but a different thing, and there are two different paradigms. So should a scientific theory explain the data or only describe the data? Newton's theory of gravity did not explain why objects attracted each other, and Descartes gave a theory to explain why, but could not actually accurately calculate the prediction. What matters more, explanation or accuracy? We had 250 years without explaining gravity, so there is not an independent paradigm answer. The paradigm, according to Thomas Kuhn, will affect the interpretation of the data. The paradigms being compared might be able to be chosen based on the data that may favor both equally. Kuhn compares scientific revolutions to political revolutions. A coup occurs and a crisis happens. A certain regime or paradigm exists, and then legal and illegal science and pseudoscience. For example, Kuhn on science. Kuhn says that science used to progress towards truth, and he expounds upon this is expounded upon from the Enlightenment period onward. Science does not lead to a final grand theory paradigm, though. This does not mean that Kuhn was a relativist. He believed that an objective truth is however attainable. Kuhn's essay on objectivity, value, judgment, and theory choice is where he talks about this. Kuhn's fallacy is that the scientific community's judgment should be trusted, but one needs to factor in the evidence. Kuhn's 5 ways. He says you need to factor in the accuracy, the consistency, the scope. So the accuracy that means that the observations need to match each other. In consistency, it has to be consistent within itself and other theories. And the evidence has to, in relation to scope, extend beyond the current laws. The simplicity would be the order's confusing phenomena, and the fruitfulness in which it provides for more research to be done, or novel research. So Kuhn has 5 ways that one can factor in the evidence. It has to be accurate, consistent. The scope has to extend beyond the current laws. It has to be simplistic, and in the sense that it orders confusing phenomena, and it has to be fruitful in the sense that it provides for more novel research. So which way is more important based on context? Perhaps we should teach all possible paradigms, not the dominant paradigm. Pedagogy is a problem for Kuhn. Kuhn suggests room for dissent, and that his epistemic values, or his 5 ways which we discussed, influence rather than determine which paradigm will be chosen, and therefore an algorithmic scientific method, an objective scientific method, does not actually exist. So there is agreement on what counts as science: applying consistent standards, logically and coherently rational judgment. Sharing a criteria is neither objective nor subjective, but intersubjective. Then we get to Emir Lakatos, which is post-Kuhnian philosophy of science. Emir Lakatos wanted to restore reason's place in scientific progress. He was a Hungarian, and he also fought the Nazi regime. And so he rebelled against the rising communists, and then he fled to Hungary. Therefore, unlike Thomas Kuhn, he did not trust rebellious revolutions. He did not trust the masses, or the scientific community, nor mob psychology. So both Kuhn and Lakatos took the history of science seriously and as important. Let's see. Lakatos said we should have one method. Kuhn says that we should not have a one method. Basically, Lakatos is saying we should not necessarily agree with the scientific community, but we need to agree with the paradigm. Kuhn would say that we need to agree with the community, but we need to work around and with a multiplicity of paradigms. So Lakatos wanted to restore the role of reason in order to evaluate science historically. He also wanted a method of science because, unlike Thomas Kuhn, he did not think the scientific community could be trusted because of mob psychology. Both Kuhn's paradigms and Lakatos's research programs guided and directed scientific questions, experiments, and data interpretation. They both are historical entities that change through the passing of time. Both the paradigms and the research programs develop anomalies, solve them, and ignore them, accept them or reject the potential abandoning of the paradigm and or program, and they both provide a theory of scientific change, which must account for change within and between paradigms and programs. So the differences between scientific paradigms and scientific research programs is that many can exist simultaneously in a given field of science, i.e. psychology, for example, Freudian psychoanalysis, behavioral psychology alongside cognitive psychology. So many programs can exist simultaneously in a given field. For example, the part of the program consisting of the essence or aspects that define what the program is, and then there needs to be a protective belt, or the part of the program that uses concepts as bridges or bridge concepts to connect the core of the program to the broad world surface. For example, you have a neo-Darwinian core, the part of the program consisting of the essence or aspects that define the program, but you also have, and for example, neo-Darwinian is the core, would be the core program, but and you would have like common ancestry, descent with modifications, etc. and then the that's the core, and then the belt, the protective belt, part of the program that uses bridge concepts to connect the core of the program to the broad surface level would be like natural selection, species relations, etc. Emir Lakatos on scientific programs, he says that if the hardcore or the hard part, the essential part of the program or the research program is proven false, then the program should be rejected. He says that the protective belt must protect the hard core. He talks about negative heuristics and counter arguments. There's a hard core at the center, which has claims and reasons for those claims. Then you have a protective belt on the outside. You have your negative heuristics and your positive heuristics. Your negative heuristics are your counter arguments, and your positive heuristics are your qualifiers. So changes are made to the protective belt, never to the hard core, and therefore the qualifiers and counter arguments can change the hard core, and those things change, but never the main parts of the paradigm or program actually do not change. They only change if the counter arguments or the qualifiers change. So all research programs have many anomalies, but what Lakatos believes is what he thinks matters most. For him, how well a theory fits the data is not primary or prime or supreme, since all programs fail to fit the data in one sense or another. What then matters more then? Well, for him, he thinks that there are two types of research programs. He says how well a program has been able to respond to anomalies. He says there's two types of research programs. There are progressive research programs where anomalies develop, expand, and mature, and leading to a mature program. He says you could have a degenerating research program where the anomalies stagnate and then problems are avoided. The progressive program accommodates anomalous data while increasing the program's predictive puzzle-solving capabilities, while a degenerating program accommodates anomalous data but does so in ways that cannot create novel predictions in relation to its problem-solving capabilities. Most programs fluctuate between progress and generation, however. Progression in the overall generalization of science increases solving power of a program. However, if degeneration wears down the heuristics, exposing the hard core to potential damage and or total destruction or falsification of the entire program. You can have a progressive example of a progressive program would be Newtonian mechanics in the 18th century. You had anomalies that inspired new research, new questions, and new applications. It did not only accommodate data, but also made novel predictions in the process, as opposed to a paradigm, or not a paradigm, but a progressive, or not a progressive, but in relation to a degenerating, in contrast to a degenerating program, the progressive program provided new research questions and applications. Generally seeing planets as point masses in order to calculate their relationship to each other planet. That's another thing. Newton setting aside, for example, certain specifics which prompted latter work to be done. You had new mathematical tools to understand more difficult complexities, such as uneven distribution of mass throughout bodies, etc. A degenerating program would be like a Marxist ideology in the 20th century. It accommodated the data by adjusting the belt, but did not make any new predictions. Marx predicted that an industrialized country would lead to revolution, but when Russia's agrarian country had a revolution without industrialized economy, Marxists adjusted the heuristics to fit the data, but the program went stagnant, probably because it was an ideology based on dialectic history from Hegel rather than empiricist history, using actual documents rather than starting with an ideology, and then interpreting the evidence in such a way that it fits into a philosophical system of belief not based on evidence. Lakatos on rationality, and Popper's problem of demarcation. Again, how Lakatos demarcates science. For example, he gives the example of alchemy and how it turned into chemistry. A research program starts as scientific and progressive, but when the program stagnates for a long time without new novel prediction, it then becomes pseudoscience. Progressive programs are generally preferred even if it resurges from a period of degeneration or stagnation. For example, artificial intelligence is a key example of this. Lakatos agrees that instant rationality is a problem because whether or not a program is progressing or degenerating depends largely and solely on historical judgments. For example, he quotes string theory versus competitor theories like M theory or brain theory or brand theory that compete against string theory. He invites a question: where should scientific research be invested? He gives an answer: investigations are determined by the scientist. He asks how long to wait without new novel predictions. He says that is a judgment call, and that methodology and reason that is something that methodology and reason cannot make. We're going to get into Feyerabend in a little bit in the next lecture, but Feyerabend thinks that if Lakatos cannot give rational guidelines for when to abandon a program, there is no rational method. Lakatos does think, however, that a degenerating program is at a high risk for falsifiability, but the degree of high risk is actually undetermined, only determined by the scientist himself. We have Lakatos that says that the job of philosophers of science is to make the history of science look rational. The more rational the history looks, the better the philosophy is. It does not matter if the story played out as the philosophy claims that it should, so long as the philosophy makes the story look rational in retrospect or retrospective rationality. Lakatos is not advocating that historians and philosophers of science should leave out facts. In fact, all facts should be mentioned, many of which can be emphasized in the footnotes. The complete story in the history of science, though, needs to be logically coherent and match one's philosophy. Sadly, most comprehensible works in the history of science will not be fully complete or convoluted, only correct, clear, and colorful. So does Popper make a bad philosopher? Well, according to Lakatos, yes, because Lakatos believes that a philosophical history of science should be heuristic, not empirical. In other words, the dangerous aspect of Lakatos reduces the history to a test of the philosophy, and is not a means primarily of discovering historical fact. According to Lakatos, the story of what actually happened is subservient to taking the major turning points in science, making sense of them, and explaining why it was rational for the science community at the time, and why they chose to abandon one paradigm, for example, Kuhn, or a program, Lakatos, in light of another. According to Popper, throughout history, most scientists do not seem to be very rational. Scientists, as well as philosophers and historians, are continually holding on to seemingly falsified theories, and many times scientists hold on to theories after they have been falsified. Is this rational or irrational? Well, both actually, because in the history of science, many who held on to falsified theories turned out to be right in the long run. You think about Einstein, who originally he denied his theory, but he ended up finding out that he was actually true. It was actually true. So, let's see here. All right. So Lakatos was in agreement on falsification, but thought that Popper's philosophy of science could not account for the need of philosophy of science to account for the history of science, explaining why the history of science is rational and not based on a reliability on the judgment of the scientific community for scientific progress. For Lakatos, reason can account for scientific progress. Do you agree with Kuhn, Popper, and Lakatos? 1, 2, 3, or all in all different degrees. We have a symmetry between science and historical cases and the philosophy of science. Evaluation of a philosophy of science is the same that a scientific research program is evaluated. How does it fit the data for the philosophy of science? Data is the historical in the historical cases themselves. How does it deal with abnormalities? How does it generate predictions about future unexamined cases? Getting the facts right is important, but also being able to make logical sense of new cases. Like research programs, one's philosophy of science can be progressive or degenerating. Another post-Kuhnian thinker, Lawrence Loudon, wrote on accepting versus pursuing a theory. Scientists may not believe in their theories in order to investigate and experiment them. But why? Could it be useful, exciting, etc.? It is rational to pursue promoting theories that show potential for puzzle solving. How good is a theory once it has solved many puzzles through historical judgment and for many years? Is this enough for the theory to be accepted? I'll let you decide.